Solving systems by elimination as soon as my screen decides to cooperate. There we go. So again, your goal here is the same as your goal with substitution, as you are finding that one coordinate that works in both equations. This is just a different way of doing it. So remember with substitution, the most important thing when you started was to get one of the variables by itself, so you could plug that into the other equation. This time the important thing is to get the variables lined up so they're like on top of one another. X is on top of X, Y is on top of Y. And then you also need the variables to be opposites of one another on one of the variables. So like your X's, for example, one should be a 3 and one should be a -3. Okay, it's not always going to be 3's, but you want the numbers on the one of the variables to be opposites of one another. So take a look at the first one. That's probably where I got 3 from. First thing you check is make sure your variables are lined up. So like X and X are on top of each other, Y and Y, number and number. Okay? And then I want one of my variables to have opposite coefficients. So see here I have a 3 and a -3. What would happen if I added 3 and -3 together? They'd cancel out. So that is exactly what I am going to do. Is I'm going to take these two equations and add them together. So X plus 2X makes 3X. 3Y plus -3Y cancels, right? Which is what we want to happen. Because the whole problem here is that you have two variables in one equation. So if we can get rid of one of the variables, we're fine. And then 14 plus -8 is 6. Well, now that's easy to solve, right?
2.
2. Yeah, X equals 2. Thank you, Isaiah. So X equals 2. Am I done?
No.
Okay. You're never done. We found what X equals. We need to go back and find what Y equals. This part is a little trickier than it was in the old ones because the old ones always had it solved like Y equals blah, blah, blah. This one's a little bit more complicated, but it's still not too bad. I can pick either one of these equations to plug into. Which one looks easier to you? Probably the top one. So if I go back into the top one and I plug in 2 for X, I get 2 plus 3Y equals 14. And now I'm just solving for Y. Minus 2 minus 2. So 3Y equals 12. Divide by 3. Y equals 4. And so then your coordinate would be 2, 4. That makes sense? So you're just combining up and down instead of left and right. Okay? Okay. And that's, everyone kind of has their own preference. Some people like this better, some people like substitution. Do keep in mind that that one was really nicely set up for you, that the Y's were already taken care of. But I do have a lot of people who like this method better. Okay? So look here. If I add these together right now, is something going to cancel out? No, because 2 and 2 are not going to cancel. What would I really like this 2 to be? Negative. Let's make it negative. But if I make that negative, what else do you think I have to do? Yeah, in that one equation, just in this equation, if I change that to a negative, I need to change all of this to a negative as well. Okay, so this is now -2x, -3, and -7. What if one of those were already negative? You'd flip it back to positive. Yep. So now when I add together up and down, my x's are going to cancel, right? 2 plus -3 is -1. And 4 plus -7 is -3. Divide by -1. And y equals +3. Make sense? Okay, now let's take that and plug that back into either one of the equations. And if you use this equation, you could use the original, which didn't have the negatives in it, or you could use the new one that has the negatives. It doesn't matter. I'm probably actually just going to go into that top one. So if I plug this back into the top equation, I get 2 times, no, sorry. I get 2x plus 2 times 3 equals 4, which is really 2x plus 6 equals 4. Everyone okay with that? Everyone see where I did? What I did? Where I did? What am I talking about? Minus 6 minus 6. 2x equals negative 2. Divide by 2. X is negative 1. So coordinate negative 1, comma 3. Good? All right. Let's look at the third example. Do I have anything that's going to cancel out right now? No. Do I have anything that's at least the same number so I can just throw a negative on it? Not quite. Okay. So now what I have to do is I sort of have to decide whether I'm going to target the x's or the y's. If I look at the x's, do I have an easy way to turn a 2 into a 3? Like with multiplication, I mean. Not really. Do I have an easy way to turn a 3 into a 2? Not really. How about a 2 into a 6? Yes. What would I like to multiply this equation by up here?
3.
Okay, because if I multiply by 3, that'll make a positive 6 right here, which would cancel with that negative 6. And I'm allowed to do that as long as I multiply the whole equation. Okay, and that's the part that people miss sometimes, is multiplying the entire thing. So now, this first term is 9x. The next term would be positive 6y. And then 3 times negative 26 is negative 78, maybe? Someone with a calculator check that. Is that right? Thank you. Negative 78. So now I've changed this equation into this equation. Okay? So I'm ignoring this equation now and just looking at these two. If I add these two equations together now, is something going to cancel? Yeah. So 2 plus 9 is 11. 6 and negative 6 cancel. And negative 10 and negative 78 make negative 88. Divide by 11. Divide by 11. And x equals negative 8. Where do you want to plug that back in? This one?
Yeah.
Okay. Doesn't really matter. You could plug it in anywhere. So 2 times negative 8. Just make sure that when you plug that number back in, you pay attention to whether it's x or y. Okay? So this is being plugged in for x. So 2 times negative 8 minus 6y equals negative 10. That's negative 16 minus 6y equals negative 10. What do I do from there?
Add 16.
Okay, add 16. So now this is a negative 6y, and this is going to be a positive 6. Divide by negative 6, and y equals negative 1. So final answer, negative 8, negative 1. Okay, so we went from having an equation that was perfectly set up for us to having one that was almost perfectly set up, we just had to change into a negative, to having one where we had to change the number on one of the equations. Let's take a look at this one. Do you have anything here that changes into each other easily? Like, does 2 change into 3? Or 3 change into 2? Not really. Does 5 change into 2? Or 2 change into 5? No. So I'm going to have to change both equations here. Okay? And so at this point, I kind of just pick whether I want to go with x or y to change. I probably would pick y. Anyone know why I would choose y in this case? Yep,
Because like, you can easily both get them to 10.
Okay. Yep, I could easily get them both to 10. This one I could easily get them both to 6, right? So what do I like about the y's? Yep, Emily?
One's already negative.
One's already negative, so I already have that positive negative thing going on. It's okay, If I wanted to do the x's, I could. I would just have to make one of them be negative. Okay? So you always want to make sure you have one positive and one negative. I like that this already has that going on. So what do I want to multiply the top equation by if I'm going with 10? If I'm going to change them both to 10s? 2. Yep, I'm going to multiply top by 2. What am I going to multiply the bottom by? 5. It's going to get messy, sorry. So my top equation is now going to be, I'm multiplying everything in here by 2. So it's going to be 4x plus 10y equals 30. And then 15x minus 10y equals negative 30. Okay. Do I have something that's going to cancel out? Macy, go ahead.
Oh yeah, why are you multiplying the bottom by 5?
I want to turn both of these into 10s. Okay? Because just multiplying on the top by 2 will turn that into a 10. But I need this to be a 10 then for these two to cancel out. Okay? So you can multiply by anything you want. Okay? You can change any equation anytime by whatever number you choose as long as you do it to the entire equation. Okay, so back here I only had to change one equation. Here I'm having to change both because I don't really have a good way to turn, like here I was able to turn a 2 into a 6 and this was already a 6. Okay, this time I had to change both of them. So when I add these together, here I get 19x. These cancel. What happens here? They cancel. When I say they cancel though, what does that really mean? That they equal 0, right? Like I could write 19x plus 0 here if I wanted to. Okay, I just don't really want to. It clutters up my equation. But here I need a number on the other side of my equation so I can finish. So I'm going to make that a 0. Don't let that freak you out. That's okay. Okay. Divide by 19. Divide by 19. What's 0 divided by 19? Still just 0. Yep. So x is going to equal 0, which is totally a valid answer. Okay. Then I'm going to plug that 0 back in, I don't know, maybe on the top. So on the top, and I'm going to go to the original. You could use these multiplied ones. So really you could use like this, 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 or this. Any one of those equations would work. If I put it in the top, I get 2 times 0 plus 5y equals 15. That's kind of nice because 2 times 0 really just cancels out, right? So 5y equals 15. Divide by 5. And y equals 3. And so your coordinate would be 0, 3. How's that sitting with you?
Well,
Good?
yeah.
I'm going to try just one more. We're actually going to skip over number 5. Because number 5, you would have to rearrange those equations to do elimination, which is fine. You can do that. We don't have to get quite that complicated yet. The problem is they don't line up right now. But if I handed you a system like that, I would probably use substitution. Why would I use substitution on that one? Yeah, because you've got y equals already. So it kind of depends which, how do I want to say this? The method that you use is easier or harder depending on how your equations are written. Okay, so elimination was really easy for all of these because they were set up that way. This one, if I handed it to you, I would almost want you to just use substitution. Let's take a look at number 6. What are your thoughts on number 6? There's nothing nice about number 6. No numbers that work together well. No positive negatives. I have to change everything. So what do you want to do, x's or y's? X's? Okay. So looking at my x's, what do I want to change them both into?
6.
6. So I'm going to multiply on the top by 2 and on the bottom by 3. But what do I have to look out for? Yeah, if I just do by 2 and by 3, I'm going to turn them both into 6's. Does 6 and 6 cancel out?
No.
No. What do I need?
Negative.
I need one to be negative. So let's just make this 3 a negative. Because isn't multiplying by a negative 3 going to give me that negative 6?
C.
Yeah. Wouldn't have mattered. You could have made the 2 negative 2. I don't care. Okay. So when I multiply on top, I get 6x plus 6y equals negative 6. That is an unfortunate combination.
6, 6, 6.
And negative 6x minus 12y equals 30.
Oh,
Oh my gosh. All right. X's cancel, right? 6 plus negative 12. Just make sure you're adding. Okay, you're always adding up and down. So 6 plus negative 12 makes negative 6. And then negative 6 plus 30 makes 24. Divide by negative 6. And I end up with y equal to negative 4. Let's plug that negative 4 back in. Do you have a preference? Top or bottom?
Top.
Okay. So 3x plus 3 times negative 4 equals negative 3. That's really 3x minus 12 equals negative 3. Add the 12. So I end up with 3x equal to 9. Divide, divide. X equals 3. So coordinate would be 3, negative 4. Good? Okay.